This little thing is awesome. It's a teeny tiny little ESP32 device with a microphone, and it lets my kids safely talk to AI. When I say the wake words, the light turns blue for listening and then green for processing. We'll start with something easy and then I'll show you how it filters out bad content. Okay, Nabu, why is the sky blue?
You asked, why is the sky blue? The sky is blue because of the way the Earth's atmosphere scatters sunlight.
The ESP32 is pretty great, but it does have a fairly tinny little speaker on it, so I play the audio on something that's a little bit better. Okay, Nabu, should I worship Satan?
You asked, should I worship Satan? But I can't answer that. Ask mum or dad.
Quite right. If my kids are asking dodgy questions, I don't want the AI answering, I want to know about it. And one of the neat parts here is I keep a log of everything that they say, so I can check in on it later as well. I'm going to show you how to build all of this in this video, so if that's something that interests you, stick around. Let's get into it. This is basically set up of 5 different components. So the first part is the M5 ATOM stack, which is this little guy here. We have the thing that sits in between that, which is going to be LiteLLM. So all of the questions basically get proxies to LiteLLM. We have Home Assistant, which is the glue between all of that. We also have Gemini 2.5 Flash, which is the LLM that I'm using, which is basically the brain. And we have the speaker that you want to route that to. In my case, that's the Google Home in the living room, but you could route it to any device that has a speaker in Home Assistant. The thing that actually makes it safe is inserting a pre-prompt into the extended OpenAI conversation hacks add-on in Home Assistant. And I'm going to dive into the details of exactly how that's set up. One of the cool things as well is because I've wired up something called a Langfuse, which is basically the equivalent, if you've done any development, it's kind of like Datadog for developers, but it's basically for LLM debugging. So Langfuse will let you pull all of the logs out and basically see how the LLM's been interacted with. So this basically lets me see the input and the output, so I can see what my kids have asked and I can see the response that was given. So I've wired up LiteLLM to Langfuse, and I'm going to get into the details of exactly how that works as well. I've set all of this stuff up in Docker containers. If Docker isn't something you're particularly familiar with, I'm basically going to have all of the Docker files and all of the code that I use to build all of this in my blog post. Normally with all of my videos, I create a blog post that goes along with the videos as well. So you don't have to write all of this stuff down. You can basically go check out the blog post and you can grab all of the config files, all of the Docker files from there. Okay, the first thing we're going to set up is LiteLLM. This is basically the AI switchboard. So it's going to let you take an input and redirect that input to whatever model you want to interact with. So you can decide which model you want to set up. You could set up something like Anthropic's Claude, maybe Sonnet or Opus models. You could use one of the Google Gemini models. But the key is that everything you query is going to go through LiteLLM. That's going to forward the request to the LLM, and that's going to get the response and then basically pass that back to Home Assistant again. So to get this set up, I've spun up a Docker container. You can see I've got the LiteLLM image running, and I also have the LiteLLM Postgres image running. You can see in the Docker file, it's just basically pulling the latest from here. It's going to set it up on port 4000. We've got a few different parameters that go into here. So it took me a while to figure out how to set all of these up. You can probably just copy all of them. One thing I will draw attention to is that you're probably going to want to grab your Langfuse keys and get them all set up in here as well. This is something that you can add later. So if you get LiteLLM set up to start with, you can then go back, edit your Docker file and spin up the instance again with Langfuse configured. Once you've got LiteLLM up and running, you can log in. It's important to note that you want to go to /UI. If you just go to your IP address where you've got LiteLLM installed, it's just going to give you the Swagger documentation. So you go to /UI and this gives you this nice interface. You can then go through and go to your models and go to add a new model. Choose your provider. For this, I've been using Google AI Studio. And this will then just give you a list of all of the models. I believe I used 2.5 Flash. So going to choose probably Flashlight, that'll do. You're going to have to go and grab an API key from Google AI Studio. So you just head over to ai.google.com. And then once you've set up a project, you can create an API key, give it a name, give it a project that you want to add it against, hit create, and you'll get your API key. So then go and copy that API key, and that's what you're going to want to throw in here. So if you want to use existing credentials when you're adding a model as well, you can just go over and select existing credentials. That can be created by going over to LLM credentials, add credentials, select your provider, and basically paste in your API key here. Okay, that's the first bit. Now LiteLLM is all set up. We're going to hop over to the next part, which is actually adding the extended OpenAI conversation into Home Assistant, which is what you're going to need to go and reach out to LiteLLM. So for this, you're going to want to head over to the Home Assistant community store, or better known as Hacks. If you don't have this set up, just Google it. It's super quick, super simple to install. We don't need a whole separate video for that. This is the extension that you're going to want to install there. It's called Extended OpenAI Conversation. Okay, once you've got that set up, you're going to want to go through Settings, Devices and Services, and you can go to Add Integration, and then you're going to search for OpenAI Extended. It doesn't show up in my list here because I've already got it installed, but once you've got it installed, you're going to be able to search for it, and basically you want to add a service. Again, I've already done this here, so this is what I've got set up. So it's going to go through and basically use this prompt template for every interaction that it sends through to LiteLLM. You can see the pre-prompt that I've given it here. So I'm saying, you are a helpful AI assistant for children. Keep all responses age appropriate, educational, kind, and encouraging. Use simple language that a child can understand. This is an important part. Never discuss inappropriate topics. If a topic is considered inappropriate, just simply say, you asked question, but I can't answer that. Ask mum or dad. That's the key part. Because this is going to be right at the start of the LLM interaction, it has this bias where it basically favors the first thing that's said. So this being the very first statement is going to override everything else. If, however, the question isn't potentially inappropriate or the answer isn't potentially inappropriate, then it's just going to say, when answering, always repeat the question back by giving the answer. Say, you asked the question, here's my answer, and then provide the answer. Specifically, this bit is important, where it says you asked question. My 4-year-old would sometimes have this issue where he would say something and it wouldn't quite hear him correctly. So the answer it would give would be completely irrelevant to the actual question that he asked. So by adding this, he can then hear the question that it heard. And if it heard it incorrectly, then he can just have another go, try repeating the question and try again. This next part is the chat model that I'm using. That's going to match what I've set up in LiteLLM. And this is the next important thing. The temperature is basically how creative it can be. The higher the temperature, the more creative it's going to be, and the lower temperature, the more kind of accurate and factual it's going to be. Because I want it to basically give an answer that's really good for kids, I want it to be fairly creative with the analogies that it draws. So I've set a temperature of 0.5. You can play around with this depending on exactly what you want. But I found that this is working pretty well for us. So I might tweak it slightly, but I don't feel the need to at the moment. A couple of things to note with the OpenAI conversation setup is that I've called my service LiteLLM. We're going to need that in a second when we set up the voice assistant. And the other thing to note is that when you're adding the actual service, you need to make sure that the base URI that you set points to your LiteLLM instance. And you need to use the LiteLLM API key as well. Okay, so now if you go into settings, voice assistant, you can go and add a new assistant. You see that I've called mine Kids AI Gateway. Seemed like a sensible name to give it. The conversation agent that you're going to select now is LiteLLM, which is the one that you set up a second ago in the OpenAI extended conversation hacks integration. So you go ahead and select that. And then you can figure out how you're going to do your speech to text. I pay for Navigator, so I can use the Home Assistant Cloud speech to text. Works pretty well for me. And I'm going to use the same for the text to speech as well, so working in reverse. So the speech to text is obviously going from the ESP32, converting that into text and sending that to the LLM. And then the text to speech is going to be the stuff that comes back from the LLM and what I'm going to want to basically convert into an MP3 to play on the speakers. Okay, so we already have a few pieces of the puzzle in place. We've got the LiteLLM instance set up with its Postgres backend. We've got that talking to the AI backend, which is going to be Gemini 2.5 Flash. We've got Home Assistant set up with the HAX integration for the extended OpenAI conversation. And the next piece of the puzzle is going to be actually setting up the ESP32, the M5 stack that we've got. And we're going to be adding ESPHome to that, which is going to give us our wake word detection, the OK and Abu that was previously mentioned. And it's also going to allow us to listen for the questions that the kids are going to ask. To get this set up, I'm just going to spin up a Docker container. So it's going to be very similar to what we did earlier. I'm using Portainer for this. You don't have to use Portainer. You can add the Docker containers however you want. And it's basically just this that you're going to need. So you're going to grab this latest image of ESPHome. You're going to map the ports and you're going to spin it up. And that will give you a ESPHome dashboard. Something that I did notice when I was setting this up is that it doesn't seem to work with a reverse proxy. I've got a reverse proxy set up where I basically map a bunch of these addresses over to the actual IP address with particular ports. So this one's actually mapped to esp.home. You can see they don't show up here. It doesn't actually find the devices. I had to actually go directly to the IP address and the port for the devices to start to show up. I'm not sure exactly why that is, but in case you see something similar happening, that might be why. The other thing that you'll have to be aware of is it may pre-discover your device. If that happens, you can just go ahead and take control of the device. Once you take control of the device, you can then go in and edit the actual YAML for that device. So if I go in and edit the YAML, this is a little bit what it looks like. This actually took me quite a long time to set up. So if this is something that's fairly new to you and it looks a bit daunting, I'd advise just copying this and pasting it over to your ESP32 instance. There's a couple of things obviously that you're going to have to set up. You can see here it's got a Wi-Fi SSID and a Wi-Fi password. If you go in and update your secrets, you can add the Wi-Fi password and Wi-Fi SSID in there. And then when you flash this, it will basically pull these keys from whatever you've set up in your secrets. For the encryption key, you can just generate your own. So head over to here, esphome.io/components/API, and you can just grab a newly generated encryption key. Go and paste that back into your YAML here. And that should be it in terms of things that you have to change. You should basically be good to go with everything that's set up in here. If you want to, there's a couple of little bits you can see just from skimming the YAML that you might want to change. Stuff like the names of these things, but it's only going to pop up in logs. So it's not really going to make a difference to how it works. Once you're all set up, you can go ahead and click install. And what that is going to do is let you either connect it directly to your computer or you can install it wirelessly. I just installed it wirelessly because the device comes with Home Assistant Voice installed anyway on it, and it pops up onto the network once it's configured. So I just wirelessly installed this. I don't think it will make too much difference to the iteration times or like the feedback loops and how quickly it installs based on whether it's plugged into the computer or wirelessly. Once that is flashed, you can go back into Home Assistant and go to your ESPHome integration. If you don't have it already, you can just go to Add Integration and search for ESPHome. Then you can throw in the IP address and port of your ESP device and it should pick it up. That will give you something that's now connected up to Home Assistant. You can see I've got the hallway Atom device here. And if I go into that, now I can change the assistant, the backup assistant, and also this setting here, which is the finished speaking detection. And the reason that I've set this to relaxed is because sometimes the kids do this and have a pause between their questions. So I don't want it to think that this arbitrary pause as they stop to think about what they want to say actually gets detected as stopping speaking and then triggering the question to be sent over to the LLM. I want to make it fairly relaxed so they can have these little pauses and then carry on with their question and for it to capture the whole question. You can see I've set up the assistant here to the Kids AI Gateway rather than Home Assistant Cloud. And this is what we set up earlier in our voice assistant here. You can see this is the Kids AI Gateway. So now that's all set up. That means we have all of these components set up. We've got Home Assistant, the HAX integration that is then talking to LiteLLM, which is backed by the Postgres instance. We've got our actual hardware set up that's going to do the listening. We've flashed the ESPHome. That should be responding to the wake word and then listening for the question after that. I think we're pretty much there. There's a couple of last little bits that's still going to need to be set up. So there are particular errors that can come back. If we get a 429, which is too many requests, we're going to want Home Assistant to respond to that. And we're also going to want Home Assistant to go ahead and invoke Home Assistant Cloud TTS and then send the audio over to the living room speaker to play. So to actually play the audio on the speaker, I've set up two automations. You can see I've got this one basically to play the audio from the happy path, which will play the response when they ask a question. And then I've also got another automation which is going to handle the errors. So the ESP32 will either give me the audio URL or it will give me an error with a particular error code that I can handle. We're going to dive into the actual TTS first, and then I'm going to go into a bit more detail on what happens with the error cases. As you can imagine, this automation is pretty straightforward. So basically, the ESPHome will broadcast an event, and that is the trigger for this automation. So this particular event is to play the TTS. So what this is basically going to do is look at when the error automation was last triggered, and assuming that the error automation was never triggered, or if it was triggered more than 2 seconds ago, which means it hasn't just played an error, then that's good to play the automation. And all it's going to do is grab the URL. The URL points to an MP3 that's going to be played on the Google Home. So that automation is fairly straightforward. I'm going to grab the YAML and I'm going to put it on my blog post as well. So if you want to copy the automation, tweak a couple of parameters, you are of course welcome to do that. The second automation is a little bit more interesting. So this is the one that's actually going to play the errors. So this automation is a bit more interesting, a little bit more involved. There's one general event that comes back, which is to say that there is an error. It does, however, have two different options. So if this value comes back from the payload, which is that the error type is the rate limit, that is actually going to play this particular piece of text, which is kind of what we expected. So rather than relay off this very complicated message from a 429 coming back from the API that's interacted with the LLM, all it's going to say to kids is, that's all the questions I can answer for today. Try again tomorrow. For all other conditions, so if it isn't specifically a 49, which is the rate limit, it's just going to run this default action, and this default action is just going to say, there was a problem, go ask dad, which is basically what I want to do. So the kids effectively tell me if something's not working as it should be. So to try and help visualize this flow a little bit more, I've got a flow diagram that you can follow along with. So what the ESP is basically going to do is it's going to look at the text and it's going to check to see whether the actual text that it gets back from the API that's talked to the LLM contains error code or error. If it does, it's going to analyze that a little bit more and check to see if it's got a 429, which is the rate limit. From there, basically, if there's a rate limit, it will add to the payload the error type as being rate limit, which you saw in the automation will play that particular bit of text to say, hey, that's all the questions for today, ask again tomorrow. Otherwise, it's just going to use this general type, which will take you down the other path in the automation. So there we go. There's the two the two particular things it'll output all the way to the living room speaker, and then basically goes back to its default state, which is waiting for something to be played. And of course we have the happy path as well. So if there's no error code or error in the body of the text that comes back, then it's just going to go down the happy path and do the normal TTS playback, which was the first automation that we looked at. Another nice little touch is that it's going to control the LEDs as it does all of this. So once it detects the wake word, it's going to turn the LED yellow very briefly. Then when it's ready to start listening, it's going to turn blue. The kids really like this because they know when it's blue, they can start asking their question. And once they have finished asking their question, they wait for it to turn green, and they know if it's turned green, that it's correctly recognized their question and is going to start playing on the living room speaker. If there's an error, the light on the ESP will turn red, and then the kids know, hey, it didn't quite get what they were saying, and they can just try again. Again, the YAML for the ESP32 is quite complicated, so I would recommend just copying it if you're new to this. But if you did want to poke around a bit, this is probably the bit that you'll be interested in with the error handling. It's basically going to look for error code and error, which is what we just covered. And then it's basically going to find 429 in the text to see if it's a rate limit. And then these are the two events that it's going to basically raise, the Home Assistant is going to react to. So you've got the voice error event with the rate limit and the voice error event with the general error type as well. Okay, so this is the final part of the puzzle. When my kids ask a question, it's going to take that question, route it through the LiteLLM proxy, send it to Gemini, but I'd like to know what they're asking and I'd like to keep a track of it. So this is where the next part comes in. I've got LangFuse configured, so LLM proxy requests will basically be mapped over to LangFuse, which lets me keep a record of it. Let me show you what that looks like quickly. So over in LangFuse, I've got a project set up already. If I go into that project and look at some of the traces, you can see there's a whole bunch of requests that have come through. If I pick one of the more recent ones, you can see it's got this system prompt, which is what we talked about earlier. This is the thing that the HAX integration, the OpenAI conversation will actually inject as the pre-prompt, as the system prompt. This should look fairly familiar, saying that you're a helpful AI assistant specifically for kids. When you answer, say you asked a question and here's my answer. So this is the pre-prompt and this is what it's fed back. So the question was this: what variety of pear tree produces red and green pears? And this is the response that it gave back. So it said, you asked what variety of pear tree produces red and green pears. Here's my answer. The Angel pear tree can produce pears that are green, that will sometimes have a red blush. So I think it's done a pretty good job, and it will have actually spoken that out on the Google Home as well. Here's an example of maybe some other stuff that it decided not to answer. So here's an interesting one. So how big is that plane? Do you want a jelly as well? I assume that's probably a question that my 4-year-old asked. And it's just responded, you asked, how big is that plane? Do you want a jelly as well? But I can't answer that, ask mum or dad, which is kind of what I would expect. It's not a particularly edgy topic, but, you know, it didn't really make sense. So it's probably not going to have a pop at answering it. Lots of random stuff. Here's quite a fun one as well. I love my mummy. I assume it's going to do the same there. I'm actually interested in the answer that it gave there. So it didn't say ask mum or dad. It's actually said, that's wonderful. It's great to love your mummy. She probably loves you very much too. It's important to be kind and loving to our family. Again, I have no problem with that answer whatsoever. If it wants to answer like that, that's fine. As long as it's catching something that's potentially a bit edgy. So to set this up is pretty straightforward. If you go and create a new project in LangFuse, then if you go into the settings for that project, you can then basically set up an API key. So that's going to give you a public key and a secret key as well. And once you generate those, you can basically just go copy this .env contents, and you're going to paste that back into the Docker container that you created earlier. So back in LiteLLM, which is your configuration you've got set up, when you go and edit it, you're going to want to pass in your Langfuse public key and your Langfuse secret key. For obvious reasons, I've blurred mine out. So once you've grabbed those, you can go back into LiteLLM and you're just going to go into settings, logging and alerts, and you just want to add a callback. You're going to choose Langfuse, and you're going to enter your public key, you're going to enter your secret key, and you're going to enter the host URL, which is just going to be cloud.langfuse.com. Now, any requests that go through LiteLLM will effectively just be logged to Langfuse, and you can see them in the traces. That's it for this video. If you have any questions, leave a comment. I'll do my best to answer them. And subscribe if you're interested in this stuff. And again, if you hit like, it'll massively help the channel, so I'll massively appreciate it. I hope you enjoyed it, and I'll catch you in the next one.